Right? This is one period, okay? So suppose that this is one period, okay? So you have a sinusoid like this. And a discrete time sinusoid you can view as sampling from this continuous time sinusoid. You take a sample every single unit of time. So the number of cycles you cover over 1 unit time is this part, which is m over n. Okay. Okay. So if m is less than capital N, then m over n is the fraction of a cycle that you're covering with one sample. So it may be possible that, after taking this number of samples, right, you are not able to return back to the same point as before, okay? But it's possible if you continue to take samples over a number of periods, you should be able to return back to the same point at least after capital N periods, okay? So if you continue to take samples, right, so on and so forth, up to, let's say, the nth period, you should be able to return back to the same point. Oh, I'm sorry, not nth period, the nth period. Nth period, but the nth sample. Okay. So if omega naught over 2 pi is this m over capital N, then you should be able to return back to the same point, after m periods by taking, capital N number of samples. Okay. All right. So again, by this formula here, we know that e to the j omega naught n is periodic with period capital N if omega naught capital N is equal to an integer multiple of 2 pi, which means that omega naught over 2 pi must be equal to some integer m over some integer capital N. Okay. So when you have omega naught over 2 pi, that is the fraction of two integers, then this is saying that omega naught over 2 pi must be a rational number. Okay? So the conclusion is that this e to the j omega naught n is periodic only if omega naught over 2 pi is a rational number. And this is because only when this is a rational number would I be able to come back to the same point after a number of periods. Okay? Now, furthermore, by problem 1.35, right, in the homework, in the problem set, you can show that if n and m are coprime, okay, then the fundamental period of xn is exactly this capital N, which is m times 2 pi over omega naught. And the fundamental frequency is just 2 pi over capital N, which is omega naught over m. Okay? All right. So what this is saying is that, by this above, we know that this will be periodic if omega naught over 2 pi is rational, okay, is a rational number. And this means that this is because only when this is rational would I be able to return back to the same point after sampling over a finite number of periods, okay? Now, what this problem proves is that if n and m are co-prime, okay, then the fundamental period is exactly this capital N, okay? So this n is just, moving to this side, dividing omega naught over 2 pi to the other side, okay? So this is saying that if n and capital N are co-prime, then you will not be able to return back to the same point earlier than capital N. Okay? All right. So this is all that is saying, right? So if they are co-prime, then you must take at least capital N samples in order to get back to the same point, okay? And the fundamental frequency is just a consequence of this, right? Fundamental frequency is just defined as 2 pi over the fundamental period, which if you substitute this inside, you get omega naught over m. So with this, we can go back and revisit the 3 examples that we looked at before.